Hi, let me start with something simple. What if the solution to energy poverty was already sitting on the ground? Not imported, not expensive, not dependent on fragile infrastructure, just waste. In Salehy, Madagascar, agricultural waste is everywhere, especially rice husks. Today, they are burnt or discarded. But what if instead they powered an entire community? That's what's up. Now, before we go further, just quickly who we are. My name is Johari and I'm from Madagascar. This project is personal to me because communities like Salehi aren't just hypothetical, they're real and they're home.
And I'm Andrew from the United States. I bring the technical and systems design perspective, working alongside Johari to make sure the solution is not just visionary, but actually deployable.
Together we build What's Up to bridge local insight with global engineering because that's what real solutions require. We're not just generating electricity, we're redesigning how a community survives, grows, and becomes resilient from the ground up. Now, this project is built for a real place. A coastal community of about 10,000 people, 2,000 families, facing unreliable electricity, frequent cyclones, and economic instability. Our goal is simple but ambitious: build a fully integrated, resilient, renewable, and circular energy system that is affordable, cyclone ready, and community owned. And we do it in two smart phases. Layer 1: proven technologies, biomass, solar, and batteries. Layer 2: emerging innovations, marine and blue energy. So we're not gambling on the future, we're building towards it. Now, here is where things get interesting. Salehi sits at the mouth of the Mangoro River, where fresh water meets the ocean. That's not just geography, that's opportunity, because it gives us access to solar energy, agricultural biomass, and eventually tidal and salinity graded energy. At the same time, the challenges are real: 2,500 millimeters of rain annually, 80 to 90% humidity, and cyclones hitting every few years. And electricity today? Unreliable, diesel based, and expensive. So the question becomes, how do you design a system that thrives in this environment, not fights it? Salehi is stuck in a cycle. No reliable energy limits economic growth. Climate vulnerability damage infrastructure. Poverty prevents investment. And it keeps on repeating. Energy isn't just missing, it's a root constraint. So instead of solving just one problem, we designed a system that solves all three altogether.
At its core, our energy system is built on four pillars. First, the rice husk biomass will give steady, controllable power. Then, the solar PV will give daytime generation. Next, the battery storage will add more reliability and peak coverage. And then for the future, we'll have marine energy for long term resilience. In the first phase alone, we're already generating nearly 10,000 kilowatt hours per day, which is more than enough to meet community demand. So from day one, it already works, and it'll only get stronger over time. And at the center of this system is a community microgrid, which you can basically think of as a local self sustaining energy network. Our household demand is grounded in reality. Each household is designed to need about 3.5 kilowatt hours per day. And that's going to be enough for lighting, cooling, refrigeration, communication, and small productive tools. It's not luxury, but it's stability. And importantly, we're separating cooking from electricity, which keeps the system much more efficient and affordable. So at full scale, for 2,000 households, we need about 7,000 kilowatt hours per day, and we're supplying 10,000 kilowatt hours today per day. So we're not just meeting the needs, but we also have a buffer which adds resilience into the system. Marine energy is then not just an upgrade, not just a dependency, it's what makes it realistic.
Now, let's talk about something most energy projects ignore: the buildings themselves. We designed dome shaped homes. Why? Because in cyclone zone, shape matters. Curved structure reduce wind stress, stronger, more stable under extreme weather. And here's where it gets even better. We use rice husk ash to generate green cement. So the same waste powering the grid is also building homes. But then we go one step further. We apply living moss layers to the wall. It sounds unconventional, but it works. Naturally cools home in high heat, retains warmth in cooler periods, reduces energy demand, no electricity required. This is passive design meeting climate reality. Now, the solar is one of the base of our system. Solar provides about 28% of the total energy. It will be installed on dome rooftops, community arrays, and it's engineered for resilience, low profile mounting, wind resistant design, and corrosion proof materials. Even some panels fell Even if some panel fell in the storm, the system keeps running. Now let's talk future. Salehy's location allows for tidal turbines, predictable constant energy, and blue energy power from salt gradient. Together, they could add thousands of kilowatt per hour daily. But here's the key. We don't depend on them upfront. We test, we validate, then we scale. That's credibility. The backbone of the system is rice husk biomass, locally sourced, constant supplies. 900 tons used annually, 5,900 kilowatts per hour per day generated, and the process is efficient. Combustion, then turbines to electricity. But the real innovation, the waste from that process becomes construction material. This is where What's Up becomes more than just energy. It becomes a closed loop system. Rice becomes husk, husk becomes energy, energy to ash, ash becomes cement, cement to housing. Zero waste, lower cost, lower emissions, local value creation. That's how you build a sustainable system, not just a power plant.
All of these different energy sources are going to be connected by a smart microgrid. It will constantly be balancing supply and demand, storing the excess energy, and it'll operate completely independently from the national grid, making it much more reliable.
And storage is hybrid: batteries for speed and water-based gravity storage for durability. High tech meets low tech, efficiency meets practicality. If one system fails, the other will support it. Now, this system isn't owned by a corporation, it's owned by the people. Through a community cooperative, households are stakeholders, revenue stays local, decisions are made by the community, and this isn't just energy access, it's energy independence.
And the economic impact will be massive. Electricity will be under 10 cents per kilowatt hour, monthly bills will be under $10, around 50 local jobs will be created, and 3,000 tons of CO2 emissions will be reduced annually. Compared to diesel systems, that's not only cheaper and cleaner, but more sustainable. So here's our timeline. Year 1 to 2, we're going to focus on building the core system. Years 3 and 4, we're going to start implementing and deploying the marine energy upgrades. And then year 5, we just optimize and replicate. So this isn't a one off project, it's a scalable model. Okay, so let's address some risks. We want to be realistic about our challenges. There's going to be a high upfront cost. The biomass emissions are non negligible. The emerging marine technology still needs more research, and there's a lot of uncertainty about collecting data in the region. However, we do address all these problems with energy diversification, redundancy, and phased deployment. So this system is not risk free, but it is risk managed.
Now, why does this design win? So, this design doesn't just solve energy, it transforms everything: energy security, climate resilience, local economy, and infrastructure. And it does it using what the community already has. So, I will leave you with this: the future of energy in vulnerable communities isn't about importing solutions. It's about unlocking what's already there. In Salehi, waste becomes powers. Power becomes resilience, and resilience becomes opportunity. And
That's
that's
what's
what's up.
up.
From waste to what to a stronger future. Thank
Thank
you.
you.